Hello, my fabulous physics students. Welcome to another force problem. And remember, force problems all surround this amazing little formula. Force equals mass times acceleration. So let's do one that might be somewhat more complicated. All right, now let's go ahead and think of a scenario. Okay, let's say that we have a lovely lady, and let's say that she's laying down in a field, just minding her own business. Let's say she's sunbathing. There she is. So there's her glasses, her sunglasses right here, and here's her hair, and she's just laying there, minding her own business. She's on a towel, and she's like, "Oh, isn't the sunshine wonderful?" Here it is, and it's shining on her. Oh, this is good. Let's call her Becca. So Becca's laying there, and she's just enjoying a wonderful time in the sun. Let's get the right color here. And then, from out of nowhere, comes out of the ground a prairie dog. There he is, and there's his mean-looking face with his whiskers. And there he is, and he jumps out, and he's snarling, and he's foaming at the mouth, and he's like, "Ugh!" And she goes, "Ah, there's a prairie dog, and it's going to kill me. Ah!" And so totally ruining her sunbathing day. And she's freaking out. She's totally petrified. And so then out from nowhere comes a guy, and he's running along. Let's call him Matty. And he's running, and he's running, and he runs up, and he's like, "I'll save you, don't worry." And so he runs up, and then he boots the so he's running this way, right? He's running this way, and then let's see, there's his big boot. He boots the prairie dog. He just runs fast as he can, and he kicks it in the head. And the prairie dog goes flying, and here's the prairie dog. He's like, there's his tail and his feet and his whiskers and his foaming mouth, and the prairie dog's like flying through the air. He's like, it just kicks him. He's like, and the prairie dog's whee! All right, and Maddie just boots this prairie dog, and Becca says, "Oh, thank you for saving me." And so then afterwards, Becca asks. She says, What just happened? She says, "What do you think the average acceleration of that prairie dog was when it left your foot?" And Maddie says, "Yeah, that's what I was wondering too." And so they say, "Well, we better go weigh it." So they go find the prairie dog, and it's dead, and they put it on their scale, right, which they keep, and they find that the prairie dog weighs 45 grams. It's a small prairie dog, but it looked really scary when it was coming out of the So anyways, so they weigh the prairie dog, the dead prairie dog, on the scale. It turns out to be 45 grams. And it just so happened that a cop was over here, and he had his radar gun, and he measured the speed of the prairie dog leaving Maddie's foot to be approximately 1.8 times 10 to the second kilometers per hour. And he walks over and says, "Son, do you know how fast that prairie dog was going?" And Maddie says, "No, but I was really hoping to, because I wanted to know what the average acceleration on the prairie dog was when I kicked it in the head." And he says, "Okay, well, you were going 1.8 times 10 to the second kilometers per hour." And Maddie said, "Cops don't use scientific notation." He says, "Yeah." And so then the other thing was, and they said, "Well, oh no, but how long did the prairie dog accelerate for? Because that's kind of important. I need that little bit of information." And right about the time that Maddie had kicked it, Becca just happened to be looking at her cell phone, and she noticed that the timer was going, and the timer said 5.0 times 10 to the negative fourth seconds was how long the prairie dog accelerated for. And so they said, "Oh, look at this. We have all the information that we need in order to find the average acceleration of the prairie dog when it left Maddie's foot." So let's go ahead and figure this out. So our initial velocity is going to be 0, and our final velocity is going to be, like the cop said, 1.8 times 10 to the second kilometers per hour, right? And let's go ahead and convert that to meters per second. So we have 1 hour over 3,600 seconds, and times, let's see, 1,000 meters in 1 kilometer. Quick little conversion here. Divide by 3,600 times 1,000 should come out to 50 meters per second. And then Maddie says, "Why didn't you just say that? That would have been easier." And Becca says, "Yeah." So then they take and they know the time. So our velocity final was 50 meters per second, and our time was 5.0 times 10 to the negative fourth seconds. Okay. So Becca had figured that out from looking at her cell phone. She's got a really sensitive cell phone timer. Yeah. So then, what are we going to do? We're gonna have to take this information, and we're gonna have to plug it into something. So what was the question? The question was, what was the average acceleration, right? So. What was the average acceleration on the prairie dog when it was struck in meters per second? Well, so in order to do that, we'll take the final velocity equals initial velocity plus acceleration times time. So the final velocity was 50 meters per second equals 0 plus acceleration times time, which is 5.0 times 10 to the negative fourth. Okay, so we find our acceleration to be 1.0 times 10 to the fifth meters per second squared. So that was a serious that was a serious kick, and there's no wonder why the prairie dog is very dead, and Becca is very thankful for. What is that? That's like 100,000 meters per second. Okay, so that's some serious acceleration. So Maddie has definitely got a future as a prairie dog kicker, or maybe even a football kicker, but the prairie dog thing seems to be working out for him. So now let's say, so they figured that out, and Becca says, "Wow, that's amazing." And Maddie says, "Yeah, I know. It's just kind of comes naturally." And then she says, "Well, what do you think the force was on your foot?" And he says, "Well, that's pretty easy to figure out because force equals ma, right? And so the force is going to equal the mass, which is 0.045 kilograms, right? Because we said he was 45 grams, times the acceleration, and the acceleration was right here. So if we multiplied 0.045 times that, we're actually going to find the force that was on his foot. So that's going to be 4.5 times 10 to the third newtons. That's going to be the force on Maddie's foot that it took in order to kick that prairie dog. So then the question might be, well, what do you think the force was of the prairie dog back on the foot? So you could ask it from either direction, because Newton's third law says for every action there's an equal reaction. So you would say, well, if the force on Maddie's foot was 4.5 times 10 to the third, the force on the prairie dog back to the foot, or from the prairie dog to the foot, was exactly opposite, negative 4.5 times 10 to the third newtons. So if we're looking at prairie dog to foot or foot to prairie dog, so foot to prairie dog was 4.5 times 10 to the third newtons, because that would be in the positive direction. And then the prairie dog had to put the same force back, which is what sent the prairie dog sailing in the air to his death. All right, so I hope that helps. And this was a pretty easy force problem, but had a lot of different factors in it. And so this is the kinds of things that you'll see on the test.